as we begin studying inverses of functions, it's really going to be practical if we can put this in a context that makes sense. Okay, so let's suppose I ask you to find the volume of a sphere, basically a ball. And the best way to do it is to use this formula, and you'll have the radius, find what the radius is. You may want to take the diameter, divide it by 2, and then you'd plug in that radius and crank out the volume. Plug in the radius, crank out the volume. Plug in the radius, crank out the volume. It's easy to do, right? If I give you radius, you plug in, you crank that out. What if I give you the volume and I ask for the radius? So if I give you volume and ask for radius, then you're going to, I'm going to go ahead and write the problem again. 4/3 pi r cubed. I'm going somewhere with this. If you were asked to find the radius when given the volume, you would have to solve this for r. Well, then if I say, okay, now do these 50 problems where I give you the volume and ask for the radius, who wants to do that? Like, no. So what you would really need to do is just, with this equation, solve for r first. That's what we're doing. So again, if I ask you to find the radius when given the volume over and over, you'd have to do the same process over and over when you could just do it from the beginning and have a formula. That's what an inverse is. An inverse, and we're going to delve into this later in the lesson, this is just the intro, but an inverse is taking what would have been the input and it's rewriting the function to make it the output. So the input would be the radius, however, I could have an input of a volume and get an output of a radius. So let's do it. We're going to solve this for r, and I want to do it correctly, but it's very sloppy. Don't write this. Please don't. The easiest way, the cheapest way, and the way that gets you made fun of in the teacher's lounge is this. You can divide by 4/3 pi, and it wipes out all those, and then you're left with volume over 4/3 pi. It's gross, it's nasty, it's right, but it's gross and it's nasty. Don't do that. Okay, so I'm going to undo all of that and we're going to fix it. Now, a big portion of this lesson is going to be how to solve these, and so I don't want to get too deep into the weeds on that right now. But what I am going to do is get rid of the 4/3 and the pi. I'm going to stretch it into 2 extra steps, or 2 separate steps. Let's multiply by 3/4. Multiplying by the reciprocal is much cleaner. Whoops, bring it back up, there we go. Those cancel. They're going to cancel because 4 goes into 4 one time, 3 goes into 3 one time. You're multiplying and dividing by lots of 1s. That changes nothing in terms of value. And so we have 3/4 volume equals pi r cubed. Okay, great. Still solving for r. Don't lose sight of that. We can divide by pi, but don't. It's not wrong, but again, it gets you made fun of in the teacher's lounge because then your work looks really sloppy and they'll be like, they were right, but man, look at that. What a sloppy mathematician. So, yeah. Instead, and it's not wrong if you divide by pi, but I'm going to multiply by the reciprocal again. Multiply by 1/pi. And that's going to give me something that's much neater. And I say it would be sloppy because you'd have a fraction involved in a fraction. It'd be a fraction in a fraction. It's called complex fractions. Later there's a whole lesson devoted to how to clean them up because they're nasty. So let's just avoid them if we can. So we have r cubed here because the pi's would cancel. Technically that pi's in the numerator. It's like pi over 1, and that one clearly is in the denominator. And so over here we have a lot of fractions multiplied together, and it may not look like it, but we do. I'm going to condense this and make it one more, like one step. So let's multiply numerators. That would be 1 times 3 times v, okay? V is a numerator. Trust me on this. This is really v over 1, right? So 1 times 3 times v, that'd be 3v. Now we'll multiply denominators. Pi times 4 times 1, that'd be pi times 4. We'll call it 4 pi. Put it in a better order. And now we have to find out what r is. Well, in order to solve for r, we would take we'll do the opposite of a cubing, which would be a cube root. So we will cube root both sides. And so even though this is technically not represented like an inverse, this gives you a taste of what's about to come, where we're going to be solving for what would have been the input, and it becomes the output. So let's finish this problem. Again, not going to be represented like the inverses that you'll see later, but final answer is this, because this cubed and this cube root, I just said the wrong thing as I pointed to them, but the cube root and the cube cancel each other out, and I'm left with the cube root of 3 times the volume over 4 pi. So again, if I gave you 50 problems for homework where you were to find the radius where I gave you the volume, you can solve it over and over, or you could do it once and then plug in the volume, crank it out, plug in the volume, crank it out, plug in the volume, crank it out, and it would go much faster. That's why we do inverses. This was a really good problem for us to begin with, so we'll have an understanding of what the process is.